Well, I want to put this video together to show you a few highlights around Logger Pro. Logger Pro may look a little different to you, whether you have the more recent version or the little less recent version, but I'm going to do it. I'm going to show you as if you were going to do what we call the Sugar Lab. So these are this X and Y where you're going to put what you're going to plot on the X and Y axis. Now there are other things that Logger Pro can do, and I think I'll show you them later on. But basically what we want to do is plot weight percent along the x-axis. So I'm going to go ahead and click on that X and it brings up this box. So I'm going to put weight percent here. And notice that the short name, I'm going to put weight percent too. Sometimes you have a longer name and then a short name. The short name actually is, as I understand it, is going to be the one that's going to show up on our graph. Units for weight percent are unitless, although I could put percent. It's kind of a little redundant. Notice while I'm in here too, I can also click on options, and then over here is if I have a certain number of decimal places or a certain number of sig figs that I know I need to limit my plotting to. And so I'm going to go ahead and choose 3 sig figs, but yours might be different. I think that should do us. I'm going to press done, and it's going to update my information there. Along the y-axis, we're going to be plotting density. So density. Short name is going to be density. Units of density in this case are going to be grams per milliliter. And looks good. I'm going to go over to my options tab and go ahead and change it to sig figs again, and I'm going to go with 3. Again, this might be different for y'all. And I'm going to click done. Notice that it went ahead and labeled my axes as I have it listed here. So I'm going to go ahead and put some weight percents here. You guys ran water, that's 0 weight percent sucrose. Then you did 2, 4, 6, and 8 grams, and you probably got different numbers, but I'm going to go ahead and say that A was 2.79% sucrose, B was 5.32%, whoops, if I hit the down arrow that would work, 5.32%. C was 8.19%, and D was 10.92%. And look what's going to happen when I hit scroll down. Notice that it truncated my 10.92% to 3 sig figs. Aha, it's smarter than I am. Or it's not smarter than I am, but it's just doing what I asked it to do. Density of water, I'm going to go ahead and put as 1.01, even though you're probably going to get like 0.9998 or something like that. For solution A, I'm going to say it was 1.15 grams per milliliter. For solution B, 1.35 grams per milliliter. Solution C, 1.42. Solution D, 1.55. And you can see, I don't know how well you can see it, but you can see as I've added those points, now we have I at least have my 5 data points right here. One for the water, A, B, C, and D. All right, so now that looks pretty good. Over in my graph part, though, I have some fixing to do. Notice that my X scale looks pretty good, but my Y scale is not good. So I'm going to go do a right click. I'm just going to do auto scale. I'm going to auto scale everything. Much better. Okay, notice now that my data points, your data points are supposed to take up, 2/3 of your graph area? That looks pretty darn good. So in this lab, we are expecting what we call a linear fit. We're expecting as your weight percent of your sucrose increases, your density will increase. So your instructions are to, I've got them right here. Your instructions are to run a linear regression. So that will be under Analyze. And we're just going to go with linear fit, linear regression, and there we go. So you're going to need a screenshot of this one as part of your lab write-up. This correlation coefficient generally shows us for linear fit how good our X and Y agree or are related. It's how well they correlate with each other. And this, the closer it is to a +1 for a positive slope like this, or a -1 for a negative slope, the closer it is to 1, absolute value of 1, I guess, then, or the absolute value is closest to 1, then the better the fit. This isn't bad. It's not great. I hope you guys do better. So there's that. Notice one thing that we're missing, that we've labeled our axes, great, and actually remember those labels came from labeling the columns over here, but we need to label our entire graph. So I'm going to do another right click, I'm going to graph options, and this first line up here says title. So a good title for your graph is Y versus X. So in our case, our Y was density, so it'd be density, either spell out versus or just VS, so versus weight percent. You can weight percent sucrose. I'll just put weight percent sugar. Okay, and there we go. Done. Okay, I noticed there was a, so that looks pretty darn good, much better. Now the goal of this lab then is, after we run these are a set of calibration standards. These are known known weight percents to give a specific density. So after this is a calibration curve, then we are going to use the calibration curve to interpolate. So I'm going to go into analyze again, and you should find an interpolate. Now when I did interpolate, it brought me up now an extra. If I kind of hover over here, you can kind of see that vertical line kind of shimmying up see there's a dot there, kind of shimmying up my calibration curve. As it moves, can you see that this box, I can't point to it, but this box over here that says weight percent and density is also changing. So let's just say you had two unknowns. Let's just say that one of your unknowns was 1.52 density. So I can go over here, find 1.52 density. Now going up, going up, going up. Almost, we're not going to have to go off. And see that that density would correspond to a weight percent of about 10.01 weight percent sugar in my sample. See how that works? And I think I mentioned in lab a little hint. If I want to go ahead and capture that on my graph, I think what we can do is kind of shimmy off this. Notice I'm trying to kind of shimmy off the till I turn into a hand. Once I turn into a hand, my interpolation is kind of frozen there. So now I can go over here and file print. You have some print options. Remember that whenever you're handing in a graph in my class, you need to hand in the graph and the table. There's one exception to that, and I'll kind of show you when that is. I think that might be in Chem 2, where I don't want all the data table. Okay, so ask me if you have any questions, but you need to print the graph and print the table. I think that's about it.